Hello. We're going to be going over the guided reading for the section called Earth in Space. Um, Remember, as we go through this guided reading, make sure that you're making any corrections you need to. Also, if you get something right, make sure you put a star or smiley face next to it. So every problem should have a mark next to it. Our learning targets here are to be able to explain how the Earth and the Sun move through space, or how the Earth moves through space in relation to the Sun, and how that results in seasons. All right, so if I add anything in my little talk here during this video that you want to write in the margins, do that, and also make sure that you add something to the class wiki. All right, so number one, the study of the moon, stars, and other objects in space is called astronomy. That's the science that we're doing right now, is astronomy. All right, that was the only one from that page. Let's see, number two. Oops. That's the one I want. Nope. There we go. All right, so number two, the axis is the imaginary line that passes through the Earth's center and the North and South Pole. So a couple things there. It's imaginary. There's not an actual pole sticking through the planet. But the Earth revolves around that certain spot, or rotates around that certain spot, I should say. And it takes 24 hours to rotate. 3, rotation is D, the spinning motion of the Earth on its axis. Another thing to say about the axis is that it's tilted at 23.5 degrees. 4, revolution is A, the movement of one object around another object. So the sun revolves, the Earth revolves around the sun. The moon revolves around the Earth. But as a planet's going in orbit around the sun, we call that one revolution. So 1 year equals 1 revolution. And 5, orbit is the path of an object as it revolves around another object. So the path that our Earth follows through space is kind of a elongated circle shape. I wish I could draw it right there, but it's called an ellipse. It's not a perfect circle orbit. It's more of an oval. 6, what causes day and night? Earth's rotation on its axis causes day and night. So as the Earth spins on its axis, it spins into the sunlight and out of the sunlight, causing day and night. A 24-hour cycle of day and night we just call that a day. We don't call it a day-night or a night-day. It's a day. 8, why is an extra day added to February every 4 years? So they're talking about leap years. The Earth's orbit around the sun takes about 365 and a quarter days. 4 years of about 365 and a quarter days each can be approximated by taking 3 years of 365 and a 4th year, a leap year, of 366. So we don't do a quarter each year, we just save those quarters for every 4th year to make a full extra day. 9, why is it warmer near the equator than the poles? This is really important for everything we do this year in Earth science. It is warmer near the equator because sunlight hits the Earth's surface more directly and is less spread out at the equator. So the equator always gets direct sunlight, whereas the poles get indirect sunlight. And the higher latitudes, like 45 degrees north and 45 degrees south, get a mix of direct and indirect depending on the season. But the equator always gets direct sunlight. 10, why does Earth have seasons? Earth has seasons because its axis is tilted as it revolves around the sun. We'll spend a lot of time on these two questions, 9 and 10. But the reason we have seasons is because the Earth is tilted on its axis at 23.5 degrees. All right, and then our last page of notes is back here. Ooh, that's small. Can I zoom in here? Oh, that's better. All right, 11. Circle the letter of each sentence that is true. C, when it's summer in the northern hemisphere, it's winter in the southern hemisphere. And D, in June, there are fewer hours of daylight and less direct sunlight in the southern hemisphere because it's winter in the southern hemisphere in June. 12. Each of the 2 days of the year when the noon sun is farthest north or south of the equator is the solstice. So the summer solstice is on June 21st, and the winter solstice is December 21st. And 13, each of the 2 days of the year when neither hemisphere is tilted toward or away from the sun is called the equinox. You see that word part, equal. And those are the autumnal or fall equinox is September 22nd, and the vernal or spring equinox is March 21st. So it's pretty much 6 months, 6 months, 6 months, 6 months. Three months, 3 months, 3 months, 3 months, every 3 months. All right, so 14, the table. So A, June 21st is the summer solstice, and it is the northern hemisphere is then tilted towards the sun. C, the autumnal equinox is September 22nd, and daytime equals nighttime on the autumnal equinox. Neither hemisphere is tilted towards the sun. Winter solstice, December 21st, it's the shortest daytime of any year, so the shortest amount of sunlight for any day of the year. And the southern hemisphere is now tilted towards the sun. And the vernal equinox is March 21st. It's the daytime equals the nighttime, and neither hemisphere is tilted because it's equal equinox. 15. Use the table to circle the letters of the statements that are true about Earth seasons in the northern hemisphere. A, when the northern hemisphere is summer, the southern hemisphere is tilted away from the sun. And D, an equinox occurs on the same days at the same time in both hemispheres. All right, so again, make any corrections. Make sure there's a little mark next to every single problem. That way I can quickly grade it. I just know it just helps me to know that you're following along in the videos. Oh, also, if you can, add to the class wiki. I always like to see people add to the class wiki.